Hi class, let's take a look at this problem here. One of the most common applications for chi-square is Benford's law. Benford's law allows us to find out when there are, or helps us to identify when there are bad checks in circulation. And Benford's law basically consists of these distributions here, where the leading digit of the check has this corresponding percentage of occurring. So the leading digit is 1, 30.1%, leading digits 2, 17.6, leading digits 3, 12.5, and so on. Okay? And here are the checks that were written right here. And they want me to group these into 3 categories. One with a leading digit of 1, the second with a leading digit 2 through 5, and then finally 6 through 9. Okay? So the best way to do this is to open this in Excel. So here is all of the checks, and I have grouped them by the categories. So there was one with a leading digit of 1. There were 10 with a leading digit between 2 and 5. There were 12 with a leading digit between 6 and 9. For a total of 23. These are the observed results. Now, with a total of 23 and the corresponding percentages per Benford's law, I can calculate the expected numbers. So I take 30.1, multiply it by 23, divide by 100, and that gives me 6.923. So on and so forth down the list. Now, group these values into the categories that we defined before. So 6.923 is in the first category, 2 through 5, which sums to 10.971, is the second category, and then finally 6 through 9 sums to 5.106 is the third category. Note that if I sum all the expected values, I get exactly 23, just as if I sum all the observed values. So I'm going to compare expected to observed. So let's do this in StatCrunch. So 1, 10, and 10 and 12. Those are the observed results, and the expected results, 6.923. And don't round these, 10.7971, 5.106. Okay? So now, stat, goodness of fit, chi-square. The observed column is var1, the expected column is var2. Compute. And here's my data. So let's continue the problem. So what is the null hypothesis? Well, the null hypothesis is going to be the sums of these percentages. So we can go back to the sheet here. If I sum 2 through 5, that gives me 47.7%. 6 through 9, 22.2%. So therefore, this is the null and this is the alternative. Oops, I'm sorry. It should have been C. Okay, at least one of the proportions is not equal to the claimed value. Okay, so it should have been C. My apologies. What is the test statistic? Well, we just found that. 14.462. What is the critical value? Well, alpha is, where's alpha? Alpha, there it is right there, 0.05. So let's go into StatCrunch, stat, calculators, and chi-square. We're looking for the right tail. And there are 3 categories. 3 minus 1 is 2. 2 degrees of freedom. Alpha is 0.05. Compute. And the critical is 5991. 5.991. So again, I went ahead and calculated the the p-value, excuse me. P-value is right here. Okay, so I can do it either way. Okay, but as you can see here, the test statistic is not between 0 and critical. The p-value is also smaller than alpha, therefore I am going to reject the null. There is sufficient evidence to warrant the claim. It appears the checks are the result of fraud. Thank you.